This is Bob Capetta from the College of the Florida Keys, and this lesson is a related rates problem. A winch at the top of a 12-meter building pulls a pipe of the same length to a vertical position as shown in the figure. I'll show you shortly. The winch pulls in a rope at the rate of negative 0.2 meters per second. Find the rate of vertical change and the rate of horizontal change at the time when y is 6. So here is our picture. The winch is pulling this pipe up. Imagine it's a drain gutter, 12 meters long, being pulled up, so it will be the same height as the building. We want to find the vertical change, which is our y variable, and our horizontal change, our x variable, at the instant when y is 6. That's what we're dealing with here. So we have to recognize there's two triangles. If we extend a horizontal from that point, this is what we get. The pipe is 12 meters long, horizontal distance to the end of that pipe is x, vertical distance to the end of that pipe is y. This is the string, the wire that is pulling that pipe up into position. So if the vertical distance is y, this distance in this triangle is 12 minus y. So we have one triangle that x is the base, 12 minus y is the height, and the hypotenuse is s. The other triangle, x is the base, y is the height, and the hypotenuse is 12. So those are the two triangles we're going to use to do our analysis. But let's start with this one. From here we get our Pythagorean equation. X squared plus 12 minus y squared is s squared. And from the other triangle we will get, of course, x squared plus y squared is 12 squared. So we're going to use our related rate strategy by taking the derivative with respect to t. So I will start with this equation. X squared plus y squared is 12 squared. Take the derivative with respect to t of both sides. So the derivative with respect to t of x squared would be 2x dx dt. Derivative with respect to t of y squared would be 2y dy dt. The derivative with respect to t of 12 squared is 0. 144 is a constant. And then relating those ideas, we could say 2y dy dt is negative 2x dx dt. And then dividing both sides by 2y, I get dy dt is negative 2x over 2y dx dt, or dy dt is negative x over y dx dt. So we're going to use that later, but this relates dy dt and dx dt. So that was built from one of our triangles. Now the other triangle we have is this one. X squared plus 12 minus y squared is s squared. What was that? Again, x squared here, 12 minus y there, s there, so x squared plus 12 minus y squared is s squared for that second triangle. Again, we're going to take the derivative with respect to t of both sides. So the derivative with respect to t of x squared is 2x dx dt. The derivative with respect to t of s squared is 2s ds dt. This one's a little trickier because we have to use the chain rule. The derivative with respect to t of 12 minus y squared, 2 times 12 minus y to the first, times the derivative with respect to t of the inside, which would be negative 1 dy dt. Again, 12 minus 1 to the first. The derivative with respect to t of 12 is 0. The derivative with respect to t of negative y is negative 1 dy dt. So this now relates all those, and then I'm going to divide everything by 2. Divide this by 2, divide this by 2, divide this by 2. And the negative one comes out and subtracts. So I get x dt minus 12 minus 1 dy dt equals s ds dt. Now, what do we know? What's our information that we're given? Well, we know x squared plus y squared is 12, and we know we're told that y is 6. So when y is 6, what is the x value? So x squared plus 36 is 144. Or x squared is 144 minus 36, or 108. So x is the square root of 108, which simplifies to 6 root 3. So when y is 6, x is 6 root 3. That's nice to know. But what about s? So we also have x squared plus 12 minus y squared is s squared. That's for our other equation. Again, when y is 6, x is 6 root 3. So x squared will be 108. 12 minus y, 12 minus 6 squared will be s squared. So I get 108 8 plus 36 is s squared, 144 is s squared, or s is 12. So when y is 6, x is 6 root 3, and s is 12. What else do we know about this? Well, the winch pulls in the rope at a rate of negative 0.2 meters per second. Let's go back and look at our image. So this is the winch is pulling in the rope. This wire is pulling the pipe up. So S is shrinking. That hypotenuse is getting smaller by a rate of negative 0.2 meters per second. So that tells me what ds dt is. ds dt will be negative 0.2. So I have a lot of things going on here. I have x dy dt minus 12 minus y dy dt equals s ds dt. And I have all kinds of variables here. So let's do some substituting. X is 6 root 3, dx dt I'm looking for. 12 minus y, 12 minus 6 just becomes 6 dy dt, and s is 12, 12 ds dt. Let's make this a little simpler by dividing everything through by 6. So I get root 3 dx dt minus dy dt equals 2 ds dt. What did we know ds dt was? ds dt was negative 0.2. So if I put that together, now I get an equation in dx dt and dy dt, where 3 dx dt minus dy dt is negative 0.4. So that's an equation we're going to use. And if you recall, way back we had another equation that related dx dt and dy dt that came from the other triangle. We had the fact that dy dt was negative x over y dx dt, and we wanted to use that. Except now we know what x and y are at that instant. X is negative 6 root 3 and y is 6. So simplifying this equation, I get dy dt is negative root 3 dx dt, which I will then plug into this equation to solve for dx dt. So I have root 3 dx dt minus dy dt is negative 0.4, but dy dt is negative root 3 dx dt. So root 3 dx dt minus negative plus root 3 dx dt, 2 root 3 dx dt is negative 0.4, which I wrote as negative 2/5, just to make it maybe a little easier to see. So I have to divide both sides by 2 root 3 to get dx dt. So dx dt is negative 2/5 with the 2 root 3 downstairs, or negative 1 over 5 root 3. So I've successfully determined dx dt. Now, can I find dy dt? Well, we see dy dt is negative root 3 times dx dt. That would be one way to do it for sure. Looks like I plugged it into this one instead. So what do we have? Root 3 dx dt minus dy dt is negative 0.4. Root 3 times negative 1 over 5 root 3 minus dy dt is negative 0.4. Negative 1/5 minus dy dt is negative 0.4, and dy dt is 0.2. But again, I probably made the wrong choice. I should have used the simpler equation to solve that. But I have indeed found the values for both dx dt and dy dt, and that will conclude this lesson.